Hello dear students, I welcome you to my this video channel. I am Dr. Yusuf Hanif Sheikh, Associate Professor, Department of Physics, Shivaji College, Kannur. Today I am going to teach you Transistor Common Collector Configuration. Circuit diagram for determining the static characteristics of an NPN transistor in common collector configuration is shown in figure in this slide. The base collector junction is reverse biased by using supply VCB. A micro emitter is connected in series with the base to measure the base current IB. A voltmeter is connected across base and collector terminals for measuring base collector voltage VCB. The emitter base junction is forward bias by using collector emitter supply VCE. A voltmeter of sufficient range is connected across collector emitter terminals to measure the collector emitter voltage VCE, and a milliammeter is connected in series with the emitter to measure the emitter current IE. The input characteristics: the curve showing the variation of base current IE with variation in base collector voltage VCB at constant collector emitter voltage VCE are called as input characteristics of the transistor in common collector configuration. The input characteristics of transistor in common collector configuration can be determined by the circuit as shown in figure in this slide. The collector emitter voltage VCE is maintained constant at a convenient value, and base collector voltage VCB is increased in steps. Corresponding values of base current IB are noted at each step. A graph is drawn between the base collector voltage VCB taken along x-axis and the base current IB taken along y-axis. The procedure is then repeated for a different but constant value of collector emitter voltage VCE. Typical input characteristics are as shown in figure in this slide. The overall shape of characteristics is quite different from those for common base or common emitter characteristics. The characteristics show that the base current IB decreases as the collector base voltage VCB increases. Further, as VCB is increased, VBE gets reduced, thereby reducing IB. Output characteristics: the curve showing the variation of emitter current IE with variation in collector emitter voltage VCE at constant base current IB are called as the output characteristics of a transistor in common collector configuration. The output characteristics of a transistor in common collector configuration can be determined by the circuit as shown in figure in this slide. Is as shown in figure in earlier slide. The base current IB is maintained constant at a convenient value, and collector emitter voltage VCE is increased in steps. Corresponding value of emitter current IE are noted at each step. A graph is drawn between collector emitter voltage VCE taken along x-axis and the emitter current IE taken along y-axis. The procedure is then repeated for a different but constant value of base current IB. The typical output characteristics are as shown in figure in this slide. As the characteristics is practically identical to the common emitter configuration, it is seen that from the curve that as collector emitter voltage VCE increases from 0, the emitter current IE varies rapidly to near saturation value for a fixed value of base current IB. After this, the emitter current becomes almost constant and is determined entirely by the base current. The value of collector emitter voltage VCE up to which collector current IC increases with VCE is called as knee voltage. As shown, a small amount of emitter current flows even when the base current IB is 0. It is the leakage current from collector to emitter ICEO. Since the main emitter current is 0, the transistor is said to be in cutoff. And thank you dear students for your patient listening. See you again in the next video. Till then, bye bye. Take care.